Hello guys and welcome back to the SimpliCode programming channel. This is Vikesh and let's get started with today's topic, which is about annotations in Java. Now annotations is a bit advanced concept, so let's understand why we need it. There would be some cases in your application where you need to provide some metadata information to the Java compiler. Now this sounds a bit complicated, but it's much simpler than that because you might not want to code everything with lot of lines of code. Rather, you want to give some smart instructions to the Java compiler so that they understand what to do. We have already seen some of the annotations, but the basic idea of annotations is to provide some shorthand metadata information about the program to the Java compiler. Generally, annotations will not have any direct effect on the operation of the code they annotate, but they provide additional logic to the code. That's the idea with annotation. Remember, they are shorthand metadata. The main use is providing information to the compiler or providing some compile time or deployment time processing, or also providing some instructions for runtime processing. We have already seen some of the annotations. If you remember, when we were dealing with inheritance, we had this override over the methods, right? This override is an annotation. This annotation, if I show you what I'm talking about, if I take you back to one of the inheritance example or the method overriding examples, and if I open the mountain bike class here, mountain bike extends bicycle, you will see this override annotation. This is an annotation. An annotation always starts with @ in Java, and the annotation name is override. Now this override is just a shorthand to tell the compiler that, hey, I am overriding this method from the base class. That's what this annotation does. If you remove the annotation, in some cases, the Java compiler might not understand what to do, and the Java compiler has to do some extra processing to figure out that this method is actually being overridden. But if you put this @override here, then the Java compiler pre-hand will know that this is coming from the base class. So you save some of the compiler processing time as well by using the annotation. It's a shorthand providing instructions to the compiler. You see exactly what I'm talking about. So this is one of the annotations which we have used, but we will look at some of the other more generic annotations, and we will also see how we can build our own custom annotation in Java. You might have also seen some other annotations like, for example, you can put @suppress warning annotation, which is a very popular annotation to suppress any kind of yellow warnings in your code. Generally, we do not recommend doing that, but if you have a use case, then you can use @suppress annotation as well. There are some other annotations as well, like @author. If you want to put your name as the author of a particular piece of code, then you can add this metadata so that whenever somebody looks at even the documentation of your code, your name will be shown there as the author. So that's the idea with annotations. So let's see how you can build your own custom annotation. Whenever you have to do that, there are multiple ways to doing that. And the first type of annotation we are going to have a look at is called marker annotation. A marker annotation is just an empty annotation without having any metadata logic at all. You can see I have defined an annotation here. I will talk about what all this means, but inside the block, there is no code here. And this is how you define a marker annotation. Marker annotation is just to provide very high level instructions to the compiler. And the way you will write your custom annotation is you will put an access modifier keyword like public. Then you will write @interface. This is the keyword which you have to use whenever you're trying to create your custom annotation. Marker or no marker doesn't matter. Whenever you define your annotation, you have to use @interface. Once you do that, then you provide a name for your annotation, which can be anything, but still not complete. You need to also provide more instructions to the compiler or the runtime processor to tell them when to execute this annotation and what the annotation type is going to be applied upon. So at first you specify when this annotation is going to be active or executed or evaluated. So here you can say @retention, which is another annotation. So you say @retention, and then you say retention policy dot whatever you want to write as. You can write it as runtime or you can write it as source. If you write it as source, then it is going to be applied at compile time. And if you select it as runtime, then the annotation is going to be processed at runtime. So this is the first thing which you need to provide. The second thing which you need to provide is where this annotation is going to be applied, whether you want this annotation to be applied to a class or to a method or to a member variable or to any other type. And that's what you define in the @target annotation. You specify the target audience for this particular annotation. And here inside the element type, you will get multiple options. You can apply this annotation to a constructor, to a field, local variable, method, module, package, record component, type, etc. So here I'm going to use type, which means it can be applied to a class or a generic element type, which generally means class type. And that's all. You can define your marker annotation like this. But generally these marker annotations does not have any logic, so you will not get much value out of it until you have very special cases. But if you have a case where you want to also run some business logic or provide some metadata logic to the compiler while defining the annotation, then you can define your annotation like this. So I've created one more annotation here, which is called my custom annotation. Again, the target audience for this is method. So this annotation can only and only be applied to methods. If you try to apply this annotation to a class, you will get an error. The retention policy is runtime. It means it is going to be processed at runtime. And I've declared a method here, which is called int value. So this is how you will declare your annotation. Now let's see how do you use this annotation. So I have a class called as my class here. And if you look at this structure of the my class, we create the class and then I create a method, which is named as say hello. And I am applying this annotation on this particular method. Remember, the target audience of this particular annotation was method, so it only be applied on method. If I try to put this on the class type here, then I get an error here. It says the annotation my custom annotation is disallowed at this location because the type specified is of type method. So the compiler will not allow you to use this at an illegal place. So you write any method and you apply your annotation, but you provide a value to the method. The int value method is going to consume this value. And inside the method, you can write any other logic. So let's see how this pans out. I create a public static void main method and I create an object of my class. So my class h equal to new my class. And after that, I'm saying h.getClass.get method. I'm basically calling the method by using reflection API. You can also call the method directly if you want, but this is how you need to call it if you want to use the annotation property value, if you want to fetch the value of the annotation. So this is just an example of me showing you how you fetch the annotation. So we created an object and then we say get class, which is going to return my class type, and then get method is going to return the method type, which has the name say hello. So this is a way to fetch a method name or a method type from a class using Java's reflection API, which is an advanced API. You might not need to use it, but for the sake of demo, I'm using this. So we fetch the class and we fetch the method. It is going to search the class for a method named say hello. If it finds the method, it is going to return the method in this variable. And then you can call method val, which was this variable, dot get annotation. Give me any annotation which is applied on this particular method. And you supply the annotation class type as well. Once you do that, you get a my custom annotation reference type. And then if you call the value method on this, you will get this value as 10. So this is a way where you can apply an annotation and you can actually see the effect of the annotation. You might not always want to do this because, like I said, these are metadata instructions to the compiler. But if you have a need to actually see what your annotation is doing, you can use the getClass.get method to first fetch the method, store it into a method type, and then call get annotation, supplying the exact annotation class type. And then you can call the exact method which is defined in your annotation. Here I've defined it as value, so I'm just calling the value method. So if I run this particular example, I get the value as 10. So I'm able to see or fetch the exact value which my annotation metadata is holding at the runtime. And this is the power of annotation. They're a very powerful concept and they're a very advanced concept. There would be very rare scenarios in your application where you need to create your custom annotations. Generally, you will be better off with your predefined annotations which are provided in Java, like @override, @author, suppress warning, etc. And that's all I'm going to cover in this particular session. And in the next session, we are going to talk about serialization in Java. If you like this video, a thumbs up would be massively appreciated. And please don't forget to subscribe to SimpliCode for more programming related videos. Thank you, and we'll meet again in the next session.